The next thing I'd like to start talking about is introduce the concrete classes for a map. So like I said, there are going to be 3 concrete classes that we're really going to look deeply into. Out of the 7, it's going to be the ones that correspond with the sets that we looked at so that we can compare and contrast. So we're going to start by looking at the HashMap concrete class, which we've already seen in our examples for map. So a quick overview here is we'll do a quick introduction on what a HashMap is. We'll look at the hierarchy of the HashMap class. We'll look at the HashMap class declaration. We'll look at the features of the HashMap class. We'll look at the constructors of the HashMap class. We'll talk about some of the HashMap methods. We'll look at some HashMap examples, and then we'll talk about how you might want to use a HashMap. Like when should you select to use that when making a decision on how you're managing your data. Okay, so quick introduction. The HashMap in Java is an unordered collection that stores elements or objects in the form of key value pairs, which we call entries. It is expressed as HashMap, and then inside of our generics type, we will have whatever the data type of key is, whatever the data type of value is. Or we could also express it as HashMap K dash comma V. So both key and value are objects. HashMap uses an object to retrieve another object. If the key is provided, its associated value can be easily retrieved from the HashMap. Keys in the map must be unique, which means we cannot use duplicate data for keys in our HashMap. If we try to insert an entry that has a duplicate key, the map replaces the old entry with the new entry, so it just does an overwrite. HashMap class is one of 4 concrete implementations of the map interface. It was added in Java 2 and is found in the java.util.hashmap package. It is efficient for locating a value and adding an entry and deleting an entry. So it's highly optimized. So the hierarchy of our HashMap, we have our HashMap, which extends the abstract class, which implements the map interface. So our HashMap class declaration, it's a generic class and it's declared as such. It's a public class HashMap with the generic type of K comma V, which extends the abstract map K comma V generic type, and then it implements the map interface, which also uses the generic type K comma V. It also implements clonable and serializable so that we can clone it and we can also serialize it. So some features of the HashMap class. 1, the underlying data structure of a HashMap is a hash table. In simple words, HashMap internally uses a hash table for storing entries. That means that accessing and adding an entry is almost as fast as accessing an array. So hash tables are incredibly fast. And so hash maps are a super effective way of storing data, especially if you want to be able to use keys that aren't of integer data types. So you don't really get a penalty for using hash maps versus arrays. You'll learn much more about this in data structures. I'll even provide for you a slide deck that explains what it means to hash and how hash tables work, but I don't think I will use lecture time to really go into that. Another feature of HashMap is in HashMaps, insertion order is not preserved. So we don't maintain the order, which means we cannot retrieve keys and values in the same order in which they've been inserted into the HashMap. Hash maps are based on the hash code of the key, not on the hash code of the values. Inside of hash maps contain only unique keys. That means no duplicate keys are allowed, but values can be duplicated, and we retrieve the values based off of the key. Heterogeneous objects are allowed for both the keys and the values. Hash maps can only have one null key, but they can have, because duplicate keys are not allowed, but you can have multiple null values if you want. Yeah, multiple null values are allowed in the hash map. Hash map is not synchronized. That means while using multiple threads on the hash map object, you will get unreliable results. HashMap implements clonable and serializable, but not random access. But despite the fact it doesn't have random access, it's still almost just as fast as arrays. HashMap is the best choice if our frequent operation is a search operation. If no element exists in a HashMap, it will throw an exception of no such element exception. And HashMap stores only object references. Therefore, we cannot use primitive data types like double or int. We have to use the wrapper class, capital integer, right? Uppercase integer or uppercase double, the reference data type. Okay, let's look at the constructors of a HashMap class. So we have the empty constructor, the default constructor used to construct an empty HashMap object with the default initial capacity of 16 and the default fill ratio or load factor of 0.75. So again, the syntax of this looks like this, or more using the generic form more reliably this, which is how we've been seeing it in our example code. We have a constructor where we can pass in an integer value, which would define the initial capacity. It would still be an empty HashMap, but you can create a larger or smaller initial capacity. We can also have a constructor where we pass in another map type to create a HashMap object by initializing the elements of the given map object. And we also have a constructor where it has two parameters. One is the initial capacity, the other is the load factor. And so the capacity is the number of buckets in which a HashMap values can be stored, and the load factor is the amount of buckets that there are before the capacity automatically is grown. So the value is a floating point number that has ranges. 0 is empty, 1.0 is full. So 0.7 would mean when the buckets are 70% full, the capacity is increased. And the default capacity is 16, essentially 16 buckets. And the load factor is 0.75. So those are your default, and that's usually sufficient enough. So you can usually just use the empty or the default constructor. Now, if you want to know more about these initial capacity and load factors, I'll give you a slide deck that has that information and inside the repo alongside these lectures. Okay, let's talk about some of these HashMap methods. So we have the clear method that will remove all of our entries from the map. We have an isEmpty method that will tell you whether the map is empty or not. We have a clone method that's used to create a shallow copy of our HashMap. So only HashMap and all entries are cloned, not the elements themselves. We have the entry set, which returns back a data type set. And so this returns the set view of all the key value pairs. We have a key set, which returns back a set data type, and that returns just the collection of keys in our HashMap. We have a put where it takes a key as the first parameter and a value as a second parameter, and this method is used to insert an entry into the map. We have a put all where we can pass in a map, and it will take all the entries in that map and add it into this map. We have a put if absent where we can pass in a key value. Key is the first parameter and a value is the second parameter. And that method adds the specified value associated with the key so long as it's not already in the map. This way, this is a good way of putting things into your map without overwriting them. So if it already exists, it would just ignore that. We have the ability to remove a element or an entry from the map using the key, passing a key in. We have a way of removing an entry from the map by passing both the key and the value in. We have the ability to check the map size, and values returns back the collection of values associated with this map, HashMap. The get method, we can go ahead and pass in a key, and it will give back the value that corresponds with that key. We have a replace where we can pass in a key value pair, and it will replace the value at that specified key. We also have a replace where we can pass in the key, the old value, and the new value, and it will replace the old value with the new value. So sometimes this method might be safer for you to do than this one, or sometimes you don't care. So you have both options. This does return back a Boolean value, whether it's successful or not, where this returns back the value that the old value. We have a contains value where we can pass in a value and it returns true or false, whether our map has that value or not. We also have a contains key where we can pass in a key object and it will return true or false, whether that key is in our map. And then an equals method that's used to compare our map to another object. And if it has the same set of entries, then they are equal. Otherwise, they are not. So let's take a look at some HashMap examples. The first example is adding entries into our HashMap. So let me go here to HashMap tester. And let me close these out here. Okay, so inside of HashMap tester, I'm just going to import my concrete class HashMap. I'm going to create a new class that has a main method so I can actually execute this. I'm going to create a new HashMap variable where the key value pair is going to be strings for the key and integer for the values. And I'm going to create a new empty HashMap. Then I'm going to query my HashMap is empty, and I'm going to save the result of that in a Boolean local variable, and I'm going to print that out. Then I'm going to put values into my HashMap where my keys are strings and my values are integers. Then I'm going to print out the state of my map, my HashMap. Then I'm going to query my HashMap for its size, and I'm going to print that out. Then I'm going to put a key value pair of null and null, and then print out my new updated state of my map. And so here you can see my HashMap is empty. Yes, that's true. The entries in my HashMap is Ricky 22, Shub is 15, John 24, Mark 30, Deep 22. The size of our HashMap is 5, and the updated entries now has the null key, null value, in addition to our pre-existing ones. Excellent. Let's take an example, another example of what we can do with HashMap and see if we try, what happens if we try to add duplicate entries. So here's our source code, but I will jump over here to our IDE so we can actually execute this. So I'm going to import my concrete class HashMap. I'm going to create a new class, HashMap tester 2. I'm going to create a main method here. I'm going to create a new variable of HMap, HashMap, and it's going to be data type HashMap where the keys are integers and the values are strings. And I'm going to just create a new empty HashMap. I'm going to put values in my HashMap where I have a key value pair. Then I'm going to print out the state of my HashMap. I'm going to print out the size of my HashMap. I'm going to put 2 new values into there, but one of those, the keys already exist. I'm going to try putting 10 again, but guava. And here I'm going to try adding a new key that doesn't exist, but with a duplicate value. And then I'm going to print out the state of my HashMap and the size after those 2 puts. And here you can see my entries here are 5 banana, 10 mango, 15 apple. The size of my HashMap is 3. Then I'm going to update my entries with those 2 puts here. And now I have 20 banana and 5 banana, so I can have duplicate values, 10 guava. Notice I overwrote the old value with the new one, right? 10 was mango, now it's guava, and then 15 apple. And so my size is only increased by 1. It's a size 4 because one of those keys already existed. Okay, I want to show you an example of how we can create a program where we perform some remove operations. So this is our source code here, but what I'd like to do is go ahead and just open in the IDE. So what I'm going to do here inside of this example program is we're going to import our concrete class HashMap. We're going to create a new class, HashMap tester 3. We're going to create a main method. Inside this main method, we're going to create a new HashMap variable, HMap. It's going to use as our key value pair character, and then as our value string, and we're going to create a new empty HashMap. Now I'm going to put characters. Now remember, character, the literal type for character uses the single quotations. the apostrophes around a single letter. So here we'll have R for red, O for orange, G for green, B for brown, W for white. And we'll print out the state of our HMap. Then we will remove a key of B, and we will get back the removed entry, and we're going to print that out. And then we'll print out the new state of our hash map. Then we're going to remove by the key value pair, and we're going to grab that object, and we're going to print out that object that gets returned back to us, and then we're going to print out the hash map. So here, notice we're going to go ahead and print out our initial state. So R for red, B for brown, G for green, W for white, O for orange. And now notice when we do the remove by just the key, what gets returned to us is the value that's associated with that key. So you could almost think of that as a kind of like a pop. Remove this key, but give me back the value. And it's actually giving me the value that's string, brown. Now I save that as an object so I can obfuscate this so we can hide what's happening, right? But you can see it's brown. And now if I print out the state of my hash map, I don't have the B brown anymore. So I have R for red, G for green, W for white, O for orange, no more B for brown. So now if we do the remove with the key value pair, character W, string white, what gets returned to me is not going to be the value. It's going to be a Boolean value of whether it was successful or not. So here the Boolean value is going to be true. Yes, this was a successful remove. And now when I go and print out the new state of my hash map, you can see it's also removed the DW entry. I'm sorry, the W white entry. So it just has R for red, G for green, and O for orange. Excellent. Now I want to show you another example where we can replace a value with another specified value inside my hash map. And so if we're going to do that, again, let me start by showing you the source code on the slides here, which will be available, but this will all be available too. All of this should be in the repo. Here, this is going to be HashMap tester 4. So what I'm going to do here is I'm going to import my HashMap concrete class. I'm going to create a new class, HashMap tester 4. I'm going to create a main method so I can actually execute this. I'm going to create a new HashMap data type, which is where the keys are going to be characters and the values are going to be string. I'm going to create a new empty hash map. I'm going to put a set of key value pairs in there, characters and strings. I'm going to print out the state of my hash map. Then I'm going to say, hey, hash map, replace the key of character B with the string black. Now it was brown when I put it in on line 9. Now we're going to replace it with black. Then what we're going to do is we're going to grab that value that we replaced out, and we're going to print that out. And then we're going to print out the new state of our hash map. And then we're going to do the same thing. We're going to say, hey, replace the key of character G with the old value of green and with the new value of greenish. And this is going to return back instead a Boolean value, true or false, whether it's successful or not. And then we're going to print out that Boolean value. So let's go ahead and run that. And here we can see, yep, this is our initial state, R for red, B for brown, G for green, W for white, O for orange. Here our replace value that we removed was brown. So here, when we do just this, it gives us back the value that gets replaced. And if we go ahead and look at our new state, we can see, oh yeah, look, brown was replaced with black. Now, when we do with the 3 parameter key, old value and new value, instead of returning back what got replaced, it returns back a true false value, whether it was successful or not. So here it was true that it was successful. And so here we can see that G is now greenish instead of green. And so the last thing I kind of want to cover in terms of HashMap is when would you want to use a HashMap? So HashMap can be the best choice if we want to perform a search operation. It's designed to rapidly find things. The best example of this kind is think of it like a phone book, because the name of the person in a phone book is a string, and then the thing you're actually searching for is the person's phone number. So whenever you're talking about any kind of phone directory, it's kind of like the reverse of an array, right? Where you're using numbers to look up other types of data. Here, you could use strings to look up numbers. And so let's understand this with a simple example program. And so this would be an example of searching our entries. And so this will be the last example we'll look at for this. Here, we'll import our hash map. Here, we'll create a class HashMap tester 5. I'll create a main method. I will create a variable of data type HashMap that we'll call HMap. Here, what we'll do is we will have a string that will represent the name. That's our key. And then we will have a long value that will represent the phone number. And so here we will put some names and phone numbers into our phone directory, into our phone book. And then what we'll do is from our map, we will get, using the name deep, the number associated with it, and then we'll print deep's phone number out. And then what we'll do is we will also call on our HMap after that, get or default. So what we'll do is we will try to get the key Steve and misspell it, and we don't even have a Steve inside of here anyway. And if that key does not exist with get or default, it will return back this default value, which will just be -1. So then we'll then show Alex's phone number and which isn't even Steve, and we'll run that. So here you could see when we go and get Deep's phone number, we have successfully gotten that value back. And then with this get or default value, if that number doesn't exist, then we can use a flag, right? A sentinel value to indicate, hey, we were unsuccessful finding the phone number. So -1 could be used as a sentinel value. Excellent. And so that's just a quick overview over the concrete class HashMap. So is there any questions about maps or iterating over maps or hash maps? If not, I will go ahead and end today's lecture, and then we'll pick up again next time talking about tree maps and linked hash maps. Excellent. Have a great day, everybody.